Okay, we are doing compositions of transformations, section 4.4. Today's goals: determine the image of a figure after a composition of transformations, describe the transformation that produces the same image as a reflection in 2 lines. The vocabulary: composition of transformations, glide, reflection. Reflections in 2 lines. A couple questions here. Learn compositions of transformations. Composition of transformations means there's more than one transformation happening on a object or figure. When a transformation is applied to a figure and then another transformation is applied to its image, the result is called a composition of transformations. So it's at least two transformations on a image or on a figure. A glide reflection is one type of composition of transformations. A glide reflection is the composition of a translation followed by a reflection in a line parallel to the translation vector. Composition of isometries. The composition of two or more isometries is an isometry. And then there's a little case. So the composition of two or more isometries, reflections, translations, or rotations result in an image that is congruent to its pre-image. All right, so let's go ahead and look at our first one, glide reflection. And let's go ahead and do what we normally would. Let's look at example 1 and do it ourselves. So example 1, we'll do it 2 different ways. The main way that I think is going to be the easiest is with the patty paper. And then we also have the algebra that we can do. It's important to know both. So we have 3 points, 1, 1, they call P, 2, 5, they call Q, 4, 2, that they call R. And go ahead and graph those. We have two transformations. The first is to translate using this vector, and then the second is after we've translated, then we reflect it over the x-axis. It's important also to note that we can do either of these in any order. We can reflect over the x-axis, then translate, and we'll land in the same spot. So let's go ahead and we'll do the patty paper first, and then we'll see how that lands with doing the math behind it. Okay, so the advice with the patty paper is make sure that we're lining up the patty paper. So I'm doing the corner of the patty paper, and it has to include, I say, the origin as a reference point. So I'll go ahead and draw a cross on the origin so that it looks like that little cube that we can, or a little square that we can keep track of. Graph each of the vertices or corners and mark each one. So that's P, that's Q, and here's R. Paying close attention to be as accurate and precise as possible. We're trying to make it land on the grid so that we can use this to see where things land as we move. If we are inaccurate, then as we do it, we'll see that it doesn't line up. So practice being accurate. I'll go ahead and this one's pretty easy. We'll look at how both of them land and some of the, if we change the order, how they'll land in different places or land in the same spot after we do both. So, and also we have some notation that we need to get out here too. So this is translate -4 on the x. Remember, this is in the x position. This is the y position. So a -4 in the x means 4 in the left direction. So we're going to the left 4 units. I'm looking at my reference point, so I'm going to the left. 1, 2, 3, 4. So I'm lining up my little grid point. I'm going to go ahead and over each point, I draw its image. So here's Q right here. We call that Q prime. Here's R prime, and P prime. Let's connect the dots and just make sure visually, does it look like it's moved 4 units to the left? And basically you're just looking at 1 point, 1, 2, 3, 4, and then yes, everything looks good. Now we are going to reflect over the x-axis. So we line everything up again. I'm doing my grid. This right here is our x-axis. So I'm just going to go ahead and draw another little reference point right here that'll help me keep track of it. And that's our x-axis. And then what I'm going to do is we flip so the line of reflection matches. So I'm flipping it over, and then I line it up again with my reference points. And then we mark each one. So this is P. And now we put 2 little prime points here. Here's our R. Put 2 of the little primes on it. We've moved it twice now. And then lastly, the Q lands right here. So it's moved twice, so we have 2 of the primes. That means the image of the image. Okay? And then this should be our final answer. Okay, so these are the values, and then we can kind of look at each one and say what those values are as coordinates. For example, P is at -3, comma, -1. So that's our P double prime. P double prime is at -3, -1, and then we can do that for each one. It should go pretty quickly. Let's look at just doing it in the other order. I won't draw it out. I'll just go ahead and show it. So if we do the reflection over the x-axis first, I have everything marked. I'll flip it over and match up. So that's this place right here. And those are the points. I can mark them down. And then I'm going to move 4 to the left. 1, 2, 3, 4. And notice it lands exactly in the same spot. So it doesn't matter which one you do first. And if you get something that's too difficult, you can kind of decide what order you think would be best. Let's go ahead and look at how we would do it mathematically. So we can do this just to 1 point and see how that applies. So if I have 1 point, let's look at P of 1, comma 1. Okay. I'm going to apply the translate to it. So I'm going to move it by -4, comma 0 on it. So that's -4 applied to the 1 and 0 applied to the other one. So this now becomes P prime is going to be equal to -3, comma 1 plus 0 is 1. Okay. So let's look. Does that land where P prime is? -1, -2, -3, 1. Yes. Right. And then when we do the reflect over the x, we can count it out. It's 1 unit from the x-axis, so then it's going to be 1 unit on the other side. So that means P double prime. Notice that the x value stays the same, -3, and then the formula is you're doing the opposite, or you change the sign of the second number. So that would be a -1 right there. Change the sign of the y in this case. So notice that is at -3, -1. So there's several different strategies we can use. The key is just having a system to kind of go through this. And that's example number 1. As we continue through, all right, so there's our example number 1. We can go ahead and complete the last few if we need to. using the format we have already. We have our check, so we can decide if we want to do this one or not to check your understanding of the level. Composition of isometries. So it's basically the same idea. We'll just follow the process and see where it lands and go from there. So we have these 3 points. We're going to rotate 180 degrees about the origin and then translate along -2, 4. Okay. And once again, we can do it both ways with the patty paper. It's kind of what I'd recommend. It's a little bit more straightforward. And then we'll see how that compares to doing it mathematically. All right. So let's try our patty paper first. So when we do this, we want to make sure that we're lining up the corner of the patty paper with the grid. That helps it be more straight. I'm going to go ahead and give myself one more space so I can make sure I have my origin, my reference. So this is our point of rotation is the origin. So I'm drawing my little cross on it. And what that does is it just helps me keep track of wherever I go. Each point, make sure you have the letters, because especially when we rotate, it's easy to, and reflect, it's easy to lose track of which one's which. All right, so I've drawn in a little box around our point of rotation, the origin in this case. I have the corners that I focused on. I'll put my pencil in the middle of the point of rotation. This time I'll go ahead and go clockwise. So as we go clockwise, recognize as we hit each quarter turn. So here's a quarter of a turn here. And then, so that's 90 degrees clockwise. I'll go ahead and keep going. And now I'm 180 degrees clockwise. Notice my origin is a little bit offline, so I'll go ahead and line it up. The more accurate you are, the more you'll be able to see where the points land. So this is where our 180 degree rotation. Here's our C. So this now becomes C prime. Here's our B. There's our B prime. And here's A. So here's our A prime. Go ahead and connect them. And then just kind of recognize visually, does that look like it's been rotated around the origin? Okay. And then the last thing is we're using this translation vector to move it. Okay. So this is our movement on the X, and this is our movement on the Y. So it's going down to, sorry, this is X, so that's left 2, and then up 4. Okay, so we can just go ahead and move it in that same direction and just keep track of the origin and how we move it. So I'm going left 2, 1, 2, and then up 4. 1, 2, 3, 4. And then this is where our new shape lands. We'll go ahead and just draw on each one and make sure we call it double prime. So here's C, double prime. Here's B, double prime. And here's A, double prime. Okay. And so then we just go ahead and say what these points are, and that completes the problem. Once again, you can do it both ways. I can do the translate first, then the rotate, or the way that I did it here. Let's go ahead and look at one point and then how it lands using the math side of it. So let's go ahead and look at point A. So A is -6, -2. Okay. Let's go ahead and rotate 180 degrees first. So if I rotate 180 degrees, the xy turns into -x, -y. That's the formula for rotating 180 degrees. And you can always just kind of compare and to see how it works. If you notice, like on this one, so this first point is -6, -2. So if I apply that on this one, my A prime is going to be 6, +2. And let's check. 1, 2, 3, 4, 5, 6, 2. And yes, there's our A prime. Then we're going to go ahead and apply the vector to it. -2, (4). So I'm subtracting 2 from the x component and I'm adding 4 to the y component. So this now gives me A double prime is equal to 6 minus 2 is 4, and 2 plus 4 is 6. So let's check. Did A land on the 0.46? A double prime. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And yes, it does check out. So we can do it either way. It's important to have your formulas kind of available so you can use these. And that's a vector right here. And doing it mathematically, or we can use the patty paper. Just make sure as you use patty paper to be as accurate as possible. That was example 2. There's our check. See if you can do it on your own. And so then now we're just going into that idea of if you have two types of transformations, it can be compared to a single transformation sometimes. So in this case, the composition of two reflections can result in the same image as a translation or a rotation. So in this case, make sure we're kind of noting the symbols here. We're starting with the original here of P, and then we are reflecting over line K, and then we are reflecting one more over line L. And what they're saying is that that's the same as if you translate and just move P all the way over. Reflections in intersecting lines. So a lot of times we're not going to see these unless they're special cases. So usually we're not going to be getting rotations that are not the main ones, 0, 90, 180, 270, and 360. So usually that'll be what we'll be using, but we're just looking at this in terms of what's happening here. So mathematically what's happening is that if we reflect over, let's see, the composition of two reflections in intersecting lines can be described by a rotation. Okay, so in this case, we're reflecting over line K, so then it lands right here at A prime, and then we're reflecting one more time over line L. So that's the same thing as if you did a rotation in this same way, and that's all it's saying here. Example 3 is just going over a few examples of that situation. A would be the first example of this one. You can take a look. And B is our example from the second one. All right, example 4. So here's that check to see if you're understanding what's going on with what we've just talked about. Example 4, are triangles ABC and DEF congruent? Congruent means they're the same. If so, what composition of transformations maps ABC on to DEF? I'll go ahead and walk you through this one, and then you can verify it with your patty paper and graph paper. So the key is to recognize how things have changed and to make sure that we are doing it in the order that they want us to. So they want us to map ABC onto DEF. So now the order is important with what they're saying. ABC, since that is first, and that's what's being mapped onto DEF, this is going to be our original or our pre-image. So you can mark this as original and pre-image. And then DEF is our image. So that's what it needs to land on top of. How can we land it on top of it? Okay. I'm going to see if the graph, if the patty paper will work on this little tiny graph here. So I'm going to do it the same way. I'm going to line up the grid with what I have here. I'm going to do a little X on the origin as my reference point. And I'm going to mark off the little endpoints. Here's my B. Here's my C. And here's my A. Then I'll go ahead and connect it. All right. So I've drawn this little graph. It's going to be more accurate if you have the larger graph paper. So this is just to help make use what we have to our benefit. All right. So how can we map it onto this one here? And notice if we move it, and even if I, if I turn it around, it maps right on it. So I think that's kind of going to be the key. What about if I have the original and I flip it over? If I flip it over, will it map on top of the other one? And there's no way I can map it on top of the other one if I flip it over. That means I know there is no reflections going on here. Can I map it if I just move it over here? No, I can't do that either. So it's a little bit of experimenting. So that means what do I need to do? Okay. I like to get the rotation out of the way first. So we'll talk about, see if we can't move it. So in this one, it says it can be mapped, our question, because triangle ABC can be mapped onto DEF by a blank about the origin. Now, the wording of this is important. To do it about the origin is a what? Rotation. So we are rotating it around the origin first. So let's see how we want to do it. Would that work? Nope, still not linked in together. Would that work? Yes, notice we're almost there to our shape. So that's a rotation of how many degrees? That's a rotation of 180 degrees and a blank along vector something. Now we are moving it left, right, up, or down. So notice if we move it 1, 2, 3 along the X direction, we map right on top of it. So what would that be? That would be the movement +3, 0. There was no Y movement. And then that would give us that congruence. So the idea is, how do you get from your original shape to land right on top of the image that you're looking for? Okay. So once again, we can do it to me, I want to stay around the origin. So if I moved it this way first, and then I tried to rotate, it's a lot harder to line it in correctly. So my advice is do any rotations first, and then it's going to be easier to move it how you need it to go so it maps on top of the other image. All right. And then example 5, describe the transformation. So you can go ahead and look over that one on your own. And then we have our practice set.